Welcome everybody to Digital Earth Academy. This program is going to be an investigation of the world's oceans. We're going to look down on the Earth from space and see what we can see. My name is Bob, and I'm a geologist at the Denver Museum of Nature and Science. And we have a program here that allows you to see as if you were up in space, investigate what kinds of features can be seen on the surface of the Earth. If we stand back from the Earth, we'll see that it's a beautiful blue color, and it's often referred to as the water planet. Why is that? Well, it turns out that over 2/3 of the Earth's surface are covered by water, covered by the oceans. The oceans are on average about 2 miles deep and very, very, very big. Let's look at the oceans. We'll start looking at the biggest ocean of all, the Pacific Ocean. This ocean is so big you can hardly see across it as you look at the globe. It spans almost the entire image. In the middle of the Pacific Ocean, there's a series of islands, one of our states. Which state do you think that is? It's Hawaii. Let's continue our investigation of the world's oceans. We're going to move to the west. We're going to see the Indian Ocean, which surrounds the peninsula of India. And then if we continue to the west, we'll find the Atlantic Ocean. It sits between Africa and South America and between North America and Europe. To the north, above the Atlantic Ocean, is the Arctic Ocean. And then to the south, towards the South Pole, is what they call the Southern Ocean. Now, these oceans are all interconnected. You can sail from one ocean to another in a ship. So the oceans are all part of a giant ocean system on the planet Earth. And that's where most of the water is, but the water is salty. Some of you have visited the ocean and you can't drink the water. It's salty. Let's investigate the salinity or the saltiness of water and do some experiments. We're going to visit with Mitch and Asa to study salinity.
This is a fun experiment you can do at home to look at the differences between some of the different bodies of water on Earth. All you need is 3 glasses of water. This one represents City Park Lake, right outside of the museum. This one represents the Pacific Ocean, and this one represents the Dead Sea in the Jordan Rift Valley. Now, there are a lot of differences between these 3 bodies of water. City Park Lake has ducks swimming around in it. The Pacific Ocean has all sorts of wildlife, like humpback whales, lobsters, sea turtles, orcas, and millions, literally millions of other creatures. Now, the Dead Sea, for a long time we thought nothing lived there. That's why we called it that, the Dead Sea. But it turns out there are things alive. They're just too small to see with the naked eye. Now, another important difference between these 3 bodies of water is their salinity. That is, how much salt is in the water. Now, City Park Lake is a freshwater lake, so almost no salt, just a little bit of pinch of salt. The Pacific Ocean is pretty salty. It's saltwater. It has about 37 parts per 1,000 salt. Now, the Dead Sea is one of the saltiest bodies of water on the whole planet. It has a lot of salt, about 337 parts per 1,000 salt. So what does this change? Well, first of all, you would want to drink from the Dead Sea. But beyond that, it also changes the density of the water. That is, it would change the way that you would move in the water. To really test the difference, we need some baby chickens. Okay, pre-baby chickens, almost baby chickens. First of all, let's see how this would swim in City Park Lake. Fell right to the bottom. Let's check the Pacific Ocean. Again, sank like a stone. Little bit slower stone, still like a stone. How about the Dead Sea? Oh, look at that. That egg popped right up to the top. And even if I poke it down, it just keeps popping right up. If you go swimming in the Dead Sea, you will not sink. What? Oh, I'm sorry. I was just teaching him how to swim. So, okay, I'm sorry. Sorry. Thank you. Thank you.
Now we're going to look at the phenomenon of temperature in the oceans. We've shown that the oceans cover this entire Earth. They're huge. And you can imagine that in the high, far north, the area is going to be cold up near the North Pole. Down by the equator, it's going to be warm. And the waters of the ocean are going to reflect this. If you try to swim up at the North Pole, it'd be very cold. If you want to go swimming near the equator, it's nice. The waters are warm. It turns out that the temperature of the water affects the density or the heaviness of the water. If you have cold water, it's relatively heavy. And if you have warm water, it's less heavy, it's lighter. And why does this matter? Well, in the oceans, there are huge currents that flow, carrying ocean water from one part of the world's oceans to another. And the warm currents flow near the surface of the water because the water is relatively light. And the cold currents flow deep in the bottoms of the oceans because the water is relatively heavy. We can experiment with this using temperature to look at how water moves. The warmer water will tend to be floating, and the colder water will tend to be sinking. Let's go to Mitch and Asa and do some experiments.
Here's a fun experiment to look at the way temperature affects the movement of water. The tank is full of room temperature water, and the ice cube has blue food coloring in it. The ice cube floats because it's less dense than the water, but as it melts, the very cold blue water sinks down to the bottom of the tank. That's because cold water is actually more dense than warm water. Now, if cold water sinks down to the bottom, what do you think will happen if we add hot water? This hot water has red food coloring, and you'll see the exact opposite happens. The hot water rises to the top and stays there. Now I'm going to add another ice cube, but I'm going to put it into the layer of hot water on top, and you'll see that it melts much faster. The temperatures of our oceans on Earth are changing all the time. The top layer is warmed by the sun, especially in sunnier places, and icebergs are melting, sending very cold water down to the bottom. And this movement of warm water rising and cold water sinking is one of the factors that drives ocean currents. Now I've sped up the video so we can see what happens over time. You'll see there's a little bit of mixing, there's a little bit of purple water, but for the most part, the hot water is staying on the top and the cold water is staying on the bottom. Now after a while, there's another very cool effect that we can see. As the hot water cools down and starts to mix with the rest of the water, it doesn't mix evenly, it sends down these little blobs. A similar phenomenon occurs when gases with different properties mix in volcanic eruptions and in the remains of dying stars.
Now we're going to consider the effects of heat on the oceans, and we're going to look at what's happening as the Earth gets a little bit warmer. The ocean water has a tremendous ability to absorb energy. And in fact, most of the energy that's come into the Earth and heating the Earth has gone into the ocean water. This means that the Earth is slowly warming, but the oceans are absorbing the bulk of the energy. We can do an experiment to indicate the ability of water to absorb heat energy. Let's go to Mitch and Asa and see what they're up to.
Now let's do an experiment to examine one of the most amazing properties of water. For this experiment, you're going to need a little bit of water, a candle, and some balloons. Only do this experiment with adult supervision. So, we're going to blow up one of the balloons. Then, we light the candle. We're going to hold the balloon into the candle flame. What do you think will happen? Let's find out. It popped. If you thought it would pop, you were right. This time, we're going to pour just a little bit of water into our balloon first. And then we'll blow it up the rest of the way. Let's find out. So far, nothing's happening. I'm definitely holding the balloon into the flame, you can see, because the latex is turning black, but it's not popping. The first balloon popped because the latex got so hot it melted and the balloon popped. This time, with even a little bit of water in there, the water takes the heat away from the edge of the balloon so it can't get hot enough to pop. Now, this is a cool experiment. But this is a cool experiment for like digital Earth ponds or maybe digital Earth puddles. But we're talking about digital Earth oceans. We're gonna need a bigger balloon. And we're gonna need a more intense heat source. Now this is gonna be amazing, but you're gonna have to join us for the regular Digital Earth program to see this experiment.
So we've investigated the effects of salinity and temperature on water, and we thought about its influence on the world's oceans. Now, join us for Digital Earth Academy, and we've got an experiment that's going to involve a blowtorch. Come join us.